Quick, graph y equals the opposite of the cosine of x by hand, two different ways. We're also going to compare and contrast the graphs and equations and look for patterns. Look at this pair of functions and this pair of functions. This is part of the family of functions series. You will need paper and straight edge, and we suggest you create grids similar to the ones at the right as needed. And as always, press pause as needed anytime during this video. The first way is with the cosine dance. Recall the graph of the cosine wave, one period. Note the 5 key points of interest. These key points are affected by the parameters in the equation, and this one there's just the 1. This is the opposite sign. This takes the opposite of each y value. So the initial point, a maximum at 0, 1, reflects to the point 0, negative 1. So we'll go ahead and plot that one. The point at the end of one period is another maximum at 2 pi, 1. This will reflect to 2 pi, negative 1, and we'll plot it. Halfway between these two maximum points is a minimum at pi, negative 1. We're going to reflect that to pi, positive 1. Halfway between the max and the min is a point of inflection at pi over 2, 0. Since the opposite of 0 is 0, that point stays in the same place, pi over 2, 0. And halfway between this min and max is another point of inflection, and the opposite of 0 is again the same, 0, so that point will stay at 3 pi over 2, 0. Pause is needed. Connect the points as a cosine wave, but reflected. So we have a smile, a frown, and a smile. This is one period of the cosine wave. We need to duplicate it to the left, and that is by going from each point back 2 pi to the left. So the minimum back 2 pi, point of inflection back 2 pi, max back 2 pi, point of inflection, and so on. Connecting the points as a cosine wave as we did before. Smile, frown, smile. Compared to the parent function in blue. And you'll notice that the graphs of y equals cosine of x, the parent function, and y equals the opposite of the cosine of x, are reflections about each other using the y-axis as the mirror. There are also reflections of each other about the line that contains these points of inflection. Pause is needed. Second way, using a table. So we'll use our unit circle values on the axes. We ask you to complete the table. Pause to do this. We're going to create a second table in green here, and this only parameter is going to have us take the opposite of each y value while the x values remain the same. So we can go ahead and fill in the x values exactly the same. But we're going to take the opposite of each y value, so the opposite of 1 is negative 1, so we'll plot 0, negative 1. The opposite of 0 is 0, pi over 2, 0. The opposite of negative 1 is positive 1, so pi, 1. Again, the opposite of 0 is 0, 3 pi over 2, 0. And the opposite of 1 back to negative 1, 2 pi, negative 1. We'll go ahead and connect the points as a cosine wave. Half of a smile, entire frown, half of a smile. And this is one period. Let's plot another one to the left using the period 2 pi, going back 2 pi to the left for each one of those points, and connect as another cosine wave. And comparing that to the parent function in blue, let's investigate an extension of this idea. On the next page are pairs of graphs. We'd like you to compare and contrast the graphs and the equations and look for patterns. All right? So here we go. This may take a minute or so. Look at each pair of graphs, compare and contrast, look for patterns. Pause is needed. All right, so the first pair of graphs, you can see that they're identical, except one of them has a positive coefficient, the other one has a negative coefficient. It's opposite as its coefficient. The rest of them are identical. Similarly here, positive 1 and its opposite, negative 1 for its coefficient. If you look at the line containing the points of inflection for each one of them, the graphs are reflections about that line containing the points of inflection, not the x-axis anymore, the line containing the points of inflection. Like here's another two pairs of graphs. We'd like you to compare and contrast those, looking for patterns. Pause is needed. Again, the equations are identical, except one of them has a positive coefficient. The other one is its opposite. Similarly here, positive 2 and negative 2, its opposite. Here I drew in the lines containing the points of inflection. And you can see that the graphs are reflections of each other about this line containing the points of inflection. So how can we use what we just discovered? So we're going to make this suggestion. When asked to graph an equation with a negative coefficient for the cosine term, like negative 3 cosine of the quantity 2x minus 1, we suggest that you graph the equation with the positive coefficient first, as we did in blue here, and then reflect that blue graph about the line containing the points of inflection, and now you have the graph. We suggest that you write this down and pause to do that. Now you try one. Given the graph y equals 2 times the cosine of x plus 1, we'd like you to graph on the same pair of axes the graph of y equals negative 2 times cosine of x plus 1. Pause is needed. Resume when you are ready. And you can see we first draw the line containing the points of inflection, and then we reflect that about that line. And our answer is this green graph right here.